Let's start this video with talking about graphing functions. So in the last video, the very first equation we looked at was y equals 2x plus 2. And at the end of the last video, I explained that you can turn an equation into a function by simply replacing the y with what we call f of x. And I explained in the last video, y and f of x are always interchangeable. So the question usually arises, so why do we have to do this function notation? And hopefully most of you have already understood what we call function notation. But let me do just a quick review. So if I'm given an equation, and like I did before, here was that equation, and we created a data table. And what we did was we chose a value for x, and we determined the value of y. So basically, we did if x equals 0, then y equals 2. And that's how we came up with the 0.02, which we went and graphed. Well, one thing about function notation, we do this same principle, but it's a little bit slicker and neater, because here I had to type out or write out if x equals 0, then y equals 2. With function notation, if you remember, what you do is, if I want to set x equals 0, I simply say f of 0 equals what? What function notation says is that you can think of this equation or this function as this one, we call it f of x, or think of this as the f function. F of 0 says every place you have an x in this function, you replace it with 0. So f of 0 means every place I have an x in my function, I replace it with 0. So that means 2 times x, but I'm going to replace x with 0, plus 2, and that equals 2. So we say f of 0 equals 2. This is saying the function equals 2 when x is 0. Now, if we were going to graph this, I explained in the last video, my ordered pair is like x and f of x. X was 0. When I plug in 0 for f of x, I get 2. So you notice I'm graphing the same point, which makes sense because this equation and this function are the same. It's just a different way of looking at it. So this is called function notation. For instance, my original data table, I then looked at x equals 1. Well, if I was given a function and I wanted to look at x equals 1, I would simply say f of 1 equals what? And all you do is you plug in the 1 for x and you do the calculation. If I plug in 1 for x, it's going to be 2 times 1. 2 plus 2 is 4. And if I end up wanting to graph the function, then x is 1. My function is 4. So for instance, if we go back and I'll grab my old graph, when we created the data table of this equation, I went and actually created the graph right here, where this is my y-axis and this is my x-axis, and here are Turns out we had like, I think 6 points to create this graph. If I had been given, instead of given this equation, if I had been given this written as a function, and then they said, please graph the function, in a sense, I would also create a data table where I would choose some x's, but instead of y, I would call this column f of x. So when x is 0, f of 0 is 2. When x is 1, f of 1 is 4. When x is -1, f of -1 is 0. You're really doing the same thing, and these numbers are going to be the same, but instead of being called values of y, we call these now the values of the function. And one of the things that students have a hard time understanding is realizing that when we're graphing functions, there's a certain kind of lingo or a certain kind of way you say things when you're looking at the graph of a function as opposed to the graph of an equation with x and y. Now, really what I could have done, if I'm going to graph this as a function, first of all, instead of saying y equals 2x plus 2, I could have just written f of x equals 2x plus 2. Notice the x-axis doesn't change. The horizontal axis is still the values of x. With an equation, the vertical axis was values of y. However, if I'm going to graph it as a function, instead of y, I would have called the vertical axis f of x. So once again, really all we're doing is interchanging y and f of x and all this stuff. But now the key is the verbiage. So let me grab one of the other equations we graphed. And let's talk about now, when you have a graph of a function, the kinds of questions you're asked are going to be different. And sometimes students can get stumped because the language sort of changes. So I'm going to assume this is the graph of a function. So I'm going to call my vertical axis f of x. Here's my horizontal axis x. Matter of fact, down here at the bottom of the page, you can't see it, is the actual, I created this graph as an equation, but instead up here I'll say, this is the graph of the function f of x equals x squared plus 2. So say you're given this graph, say it's some kind of problem, and then you're asked to answer some questions about this graph, which really means you're answering questions about this equation. So once again, normally when I do the graph, I would put arrows on the end, which means this goes on forever and ever. Now let's look at some questions. Matter of fact, I'm going to write some of these questions down because I want you to get an understanding of how the language is going to sort of change when we start looking at graphs of functions. Because in calculus, 90% of the time, we're talking about graphs of functions. We're not talking about graphs where y is your vertical axis. So here's one that's pretty straightforward. Here's a question. Given a graph like this, you might be asked, what does f of x equal when x equals 2? So what you do is, the whole key to answering this is, since they give you the value of x, this value of x tells you where to go on the graph. So x is 2 is right here. and you go up to the graph. So we're looking at this point right here. As an ordered pair, it's 2. They gotta be careful of the 0 to 10. So these are each 2, 2, 4, 6. So that point is actually 2, 6. Now really, 2 is x, 6 is f of x. So once again, 6 is like the vertical axis, 2 is the horizontal axis, right? Straightforward graphing. So when it says, what does f of x equal when x equals 2? The value of x leads you to that point on the graph, and then you figure out the value, the vertical number for this point, which is 6, and that's your answer. You would say f of x equals 6. Or, I mean, this is perfectly fine. If you want to be really precise and fancy, you could say f of 2 equals 6. Because when you say, what does f of x equal when x is 2? Matter of fact, maybe I'll make that a second question. What does f of 2 equal? F of 2 says, I'm looking for the point where x is 2. So once again, I go on my x-axis and I find 2. And when x is 2, I go up to my graph. And then the vertical value of this point, which is 6, is my f of x. Although I could call it f of 2 because x is 2. So what does f of 2 equal? F of 2 equals 6. Now just to show you, sometimes they just change a word or two and people get confused, although you have to get used to it because sometimes in the world of math, they just assume that you know what they're talking about, so they don't spell out every single word. They sort of leave some things out because they assume you know what's going on. So for an example, look at this first question. What does f of x equal when x equals 2? I could have said, what does the function equal when x equals 2? Actually, all I've done here is, instead of writing f of x, I just use the word function because f of x is the function. So what does the function equal when x is 2? If I was given that question, this is saying, okay, go on my x-axis and find the value of 2, go up to my graph. At that point, the vertical value of this point is my function. So what does the function equal when x is 2? I go to this point here. This, you can think of this vertical axis as the values of the function. We call it f of x, but in a very real sense, a lot of times they just refer to this as the value of the function. When x is 2, the value of the function is 6. Now, a lot of times when you write your answer, you won't write the word function. You'll go back and just use the f of x notation because this means function. Here's where it gets really tricky. How about if I say, well, let me think about this. Is there more questions? What is it? Let's flip it around. For what value of x does the function equal to? So it's interesting, I sort of flipped it now. They've given you the value of the function, and they're wanting you to say, okay, what's the value of x? All the previous problems, they've given you the value of x, and that allows you to go find x equals 2 on the x-axis, and then you go up and find the point on the graph. Here, they sort of flip the script. Now they give you the value of the function, and they say, when the function's 2, what's the value of x? So that means this is a point on my graph. How do I find this point on my graph? Well, now I go on the vertical axis and I find the place where the function equals 2. So 2, 4, 6, the function is 2 is right here. Turns out when I move up to 2 here, I'm actually right on top of the graph. So in a sense, this is the point I'm looking at. So when the function is 2, this is where I'm at on my graph. And what's the value of x at this point? Well, the value of x is 0. So the answer is, for what value of x does the function equal 2? X is 0. Because this point here is 0, 2. The function's 2, the value of x is 0. Now, sometimes even this wording will change. They may say this. Where does the function? Actually, what I'm going to do, before I do this, just to make it a little more clear, let me do one more question just like this, except I'm going to choose a different value for the function. How about I say, for what value of x does the function equal 6? So once again, on this question, they've given me the value of the function, and they want to know what the value of x is. So I go on my vertical axis to where the function is 6, which is right here, and then I move, with the function is 6, I move to find the point on the graph. So the function is 6 is right here, and what's my value of x? 2. Oh, sorry, you couldn't see that. So once again, I'm going to where the function is 6, and then I move across to get on my graph, and I say, at this point on the graph, what's the value of x? 2. So therefore, for what value of x does the function equal 6? X equals 2. However, some of you looking at this probably had the thought, okay, so we're going to go to where the function is 6, and then we're going to go to a point on the graph where the function is 6, and we give it right here. But someone might say, well, you know, the function is 6. What about if we went the other direction? Because right here, at this point on the graph, the function is also 6. Turns out x is -2. So this point here is a -2, 6. So something interesting has happened. There are actually 2 points on this graph where the function equals 6, right? 2, 6, the function is 6 over here, -2, 6. I actually have 2 different answers to this question. For what value of x does the function equal 6? Well, x equals 2 for this point. But I also have to say, you know what? X could also be -2. I have to give the solution, the answer for both possible points on the graph. So you'll have that sometimes. Sometimes you'll be asked a question about a graph, and there will actually be more than one answer. Now, here's where I want to get into some of the sort of verbiage. So this, for what value of x does the function equal 6? That is laid out very clearly, and here's the answer. But here's what they'll do. Sometimes, because maybe math people don't like to talk as much, instead of saying all these words here, they try and squeeze it down to more like the essentials. So sometimes they'll say, instead of saying it like this, they'll say, where does the function, maybe I'll do it like this, where does the function equal 6? So what's changed? Well, in this first one, it's pretty clear. For what value of x does the function equal 6? They sort of spell it out. The answer are going to be values of x. Here, you notice x is never mentioned in this question, excuse me. All they say is, where does the function equal 6? So this is where, in the world of math, you have to sort of understand what they're really asking. They don't explicitly ask the value of x. They just say, where does the function equal 6? But what this means is there's really no other answer. I mean, what they're really looking for are the values of x where the function equals 6. So for this question, where does the function equal 6? You would go to your graph, you'd go on the vertical axis where the function is 6, and then you would find all the points on your graph where the function is 6. So when they say, where does the function equal 6? Well, it's at this point and at this point. So when they say the where, it's sort of obvious they're asking for the values of x. In other words, they don't want to have to keep saying every time you look at a graph of a function, what's the value of x? What's the value of x? They just say, where does the function equal 6? And you just know what they're really asking you for are the values of x. As a matter of fact, sometimes they want to really make it simple and direct. They just say, where does f of x equal 6? In a sense, what they're asking is, where does the function equal 6? What they're really asking is, what are the values of x where the function equals 6? So where does f of x equal 6? You go find on your graph where the function equals 6. Once again, you got 2 points. Where It's like, where are these 2 points? It's almost like the x-axis is like a pointer, or it's like it tells you where you're supposed to be. The function is 6. So we want to go on the graph where the function is 6. And how do we now tell people where these 2 points are? Well, you give them the values of x. You know the function is 6. If you tell them 2 and minus 2, first of all, we tell them there's 2 points where the function is 6. And we tell them exactly where the points are. 2, 6, right here, and -2, 6, right here. So once again, as you're looking at graphs, oftentimes they're speaking in terms of functions. And these are the kinds of questions they will ask you. As a matter of fact, let me look at my last graph, and we'll just do a few more of these. In fact, maybe I'll ask you the question and pause for just a minute and see if you can answer it yourself. So I'm going to make these up as we go. So how about the first one I'll say, and I'm going to use the very sort of simple, short, cryptic questions, not the long, detailed ones, just so you get used to answering these very short questions. How about I say, now here's something you might be asked this. How about what is the function for x equals -2? Okay, x equals -2 tells you which point you're looking at on the graph, right? So if we look once again, x equals -2 is right here. Once x is -2, we go down to the actual point on the graph. And be careful of the y-axis because this is -2 right here. So at this point here, x is -2, the function's -2. So what's the function for f(x) equals -2? You just say f of x equals -2. You know what that might say? Might not be a question, it might just be f of -2 equals what? It looks so simple, but there's a lot that's involved there. They're saying, first of all, x is -2, and what's the function going to be equal to when x is -2? So once again, x is -2 is like your pointer. This tells you, it points you, it leads you to the point on the graph we're talking about. So once again, x -2, we'll go down here. F of negative, what's the function when x is -2? Of course, you would just say -2. How about f of 1 equals what? This one here is defining what x is. So that's like your pointer. So if you know x is 1, let's go find that point on the graph. Well, here's my x-axis, here's x is 1, so that means there's a point I'm looking at. It's 1, -2. So what's the function when x is 1, -2? Now let's flip it around. Let's do the easy short notation. Where does f of x equal to? Now, really, what they're asking us for, the answer is going to be a value or maybe values for x. I never actually ask for the values of x. But once again, they give you the value of the function. So in this case, this is like your pointer. This tells me, this helps me to go find the point or the points on the graph that I'm interested in. So where does f of x equal to is where the function 2, the function is the vertical. So once again, 2 is right here, the value of 2. So when my vertical value is 2, you know, where are the points on the graph that the function is 2? Well, first of all, turns out I'm right on top of 1 here. But if I go here, so sort of like you look along, you scan back and forth along the horizontal line where the function is 2, and you see here, here's another point on the graph, like for instance, this point, the x, it's a little tricky here. This is -1, -2. This is like -1.5. Or a lot of times in math, these are called mixed numbers. They might like to write it -3/2. This point here is another point where the function equals 2. So that point there is 0, 2, right? Because the value of x is 0. And then it looks like there's actually one more. Now here's a case where sometimes when you look at a graph, it's not always so easy. Because you know, 2.5 is right here, but it's a little bit past it. So in a sense, I really don't know precisely what that value is there. Of course, I'm just sort of asking these questions as I go, and as it turns out, that one's a little tricky. How about here's one that has a precise answer. So the point is, if I answer this question, where does f of x equals 2? I've got x equals -3/2, x equals 0, and I'm not sure what that value is. I mean, it could be like, if 3 is here, it could be like 2.6. I can't really tell for sure. But here's one I do know for sure. Where does f of x equal 8? So what do? We're going to find the point or the points on the graph where the function equals 8. The function is the vertical axis. 8 is actually right here. So I'm looking at this horizontal line, and I see here's going to be a point on my graph where the function equals 8. So that point there is actually, looks like it's x is 3 and the function is 8. So the answer to this, x equals 3. And just one more, let me give you this. Wait a second, let's see if you come up with the answer. Where does f of x equal negative 22? So let me pause a second, maybe 5 seconds, see if you can answer that question. So I want to find on this graph where the function equals negative 22. Negative 20 is here. I know each of these lines is a distance of 2. So negative 22 is right here. So now I go over and I realize that right there, that's where my function is negative 22. So this point is x, negative 22. Well, what's x? When I go up to here, here's my x. Looks like it's minus 3. So where does the function equal negative 22? When x equals negative 3. All right, now in the next video, let's talk about something that's very important. All of these answers have just been finding points on my graph. But what if I ask a question like this? Or maybe I think the correct is where is, not where does. Where is, remember inequalities? You have to use those a lot in calculus. Where is f of x greater than 0? You know, another way to rephrase that question, which you're going to have a lot. Where is f of x positive? We're asking, where is this function greater than 0? If something is greater than 0, that means it's a positive number. So sometimes I'll just state the question, where is f of x positive? Now we'll talk about this in the next video, but just to give you a sneak preview. So I'm going to look at my function, and I'm going to look at where is the function greater than 0? Well, the function, once again, is my vertical. So let's just do this. Let's just start moving along this function. Down here, if I would stop and look at these points, let me just ask a simple question. Is the function down here have a positive or negative value? Well, we already know right here, if I stopped right here, what's the value of the function? Negative 2. If I went way down here, what's the value of the function here? Negative 22. Hopefully you can see that every point, every value of the function for here, it's always going to be a negative number. or we can say it's going to be less than 0. But then something happens. Right here, when my function crosses the x-axis, we call that the x-intercept, which we're going to talk about later. But then from now on, as I keep looking at my function, what happens? All of a sudden, when I look at the function up here, is the function positive or negative? All of a sudden, all of these values of the function are now positive numbers. So the function is positive here, all the way here, here, until, look at, I cross the x-axis again. And then what does the function do? The function goes negative because once again, the vertical axis is the value of the function. So this little part's negative. It crosses the x-axis again. And from here on out, the function is positive. So you know what? If they're asking the question, where is f of x greater than 0, or where is f of x positive? It's not just one point. It's actually, it's almost like it's this whole section of the function, this whole thing for each point along here, the function's positive. And then actually over here, so it's like the function is positive here, the function is positive here. So if the question is where, now by where, they're asking for the values of x. So they could have said, for what values of x is f of x greater than 0? For what values of x is f of x positive? Well, you know what? It's this here. It's not just one value of x. It starts here and it goes to here. It's almost like the function goes positive when x is at this value, a little bit less than -2. The function stays positive until x is 1/2. It ends up going positive again right about here, and then it stays positive. You know what we would say, it stays positive till infinity. So all the previous questions, the answers were like single values or points. But for this kind of question, it's this whole range. It's when x is between here and here, the function's positive. When x is between here and infinity, the function's positive. So the answer is this whole range of values of x, or the way we express that and write that kind of answer is as an interval. An interval is where you give, it can be confusing because it's a parenthesis. So you give the smallest value in your interval and the largest value. So actually for this one, we have 2 different intervals. So we write for each one of these. So here, the smallest value of x is whatever this is right here. Maybe it's like -1.8. And for this whole interval, the largest value is 1/2. So we go from negative, I could say -1.8 to 1/2. And there's another one. And once again, the value of x, this is the smallest value of x for this part of the graph. And we'll say it's maybe 2.3. Starts at 2.3. And x, since this goes on forever, what is x going to be? It's actually infinity. All right, so this, what I've done here, this is like a sneak peek. You may not have quite fully understood what I've done. But this is the kind of thing we're going to do next, because in calculus, with functions and graphs, the answers are oftentimes intervals. They're not points, they're intervals. So we have to understand that.